Happy Monday, everybody. Hope you had a great weekend for those of you that are keeping up with the assignments and that you were able to get outside and enjoy some of the weather because it was gorgeous out this weekend. Okay, so moving on forward, here we go with what are called common logarithms, or sometimes referred to as the change of base. Okay, so in your calculator, maybe you have noticed that you do have a log key, L-O-G, log key. All right, so in that key, you got this guy right there. This what calculates a common log base 10. Okay, so again, it's like when you see the square root key. Okay, the square root key right here does not actually have the little 2 in the index. It's an assumed little 2. Okay, so that's the same idea as a common log. When you do not see a base number, that is an assumed base 10. So again, this would not be here. You're not going to see this because those are common. So calculators will calculate logarithms in base 10. If you see a logarithm without a base, you may assume it is base 10. So just like I did here. So literally you just hit your log key, log, and then you would type in 45, hit enter, and you get 1.65. All right, so this is 1.65. Now remember what logarithms mean. This logarithm right there means that you are taking 10 to what power gives you 45. That's what this logarithm means. So if we took the value of 10 and I took it to the 1.65 approximately, you would get about 45. Okay, so 10 to the 1.65, because I did approximate it, I get 44.66. Okay, because again, I just approximated that decimal. All right, so that's all we're doing for those. So log 3.213, you just type that into your calculator. So I actually just use my own calculator. So log 3.213, and you get 0.507. So again, that means 10 to the 0.507 is about 3.213. Log 3 divided by 4, so log of 3/4, that's a negative 0.125. So that means again you're taking 10 to the negative 0.125, and that gives you about 3/4. Okay, calculators also do calculate natural logs as well. So if you look right below your log key, you have a natural log key. And remember, natural logs mean log base e. So we wouldn't actually type in a log base e. So natural log of 5, again, it does mean that you have e to the 5th power, or excuse me, log base e of 5, but you're calculating, those are special. Remember, special keys, log base e means natural log. So if you type in natural log of 5, here's the natural log key right here, here's log, natural log down here in this red button, natural log 5, hit enter, we get 1.609. So go back to my notes. So 1.069. And what that means, because it was log base e, it means e to the 1.069 is approximately 5. Now you do have an e key. So if we go back to the calculator, right here, the natural log, if you hit the second key and then the natural log key, that's the e key. So if I take e to the 1.609, hit enter, you get pretty close to 5. So that's what that means, okay? So natural log of 3, oops, I guess I have those flip-flops, huh? So those 60, there we go, 609. Okay, so I have natural log of 3.144. That gives me 1.145. That means e to the 1.145 is approximately 3.144. Natural log of 5/8 does give me negative 0.47. So e to the negative 0.47 is approximately 5/8. Okay, so where this now leads towards is, what if we don't have a common log base 10? Well, our calculator only calculates base 10, so we will use what's called a common log or a change of base. So if we have a logarithm that's, say, log base b of a, then what we're going to have to do is use this common log form. Now, when I have this base b, the b cannot be equal to 1, and it can't be a negative either. Also, the a cannot equal 1, and it cannot equal a negative either. All right, so those have to be positive values greater than 1. So how do we write this as a common log so that the calculator will calculate it? Whoop. Where'd we go? There we go. All right, so what is going on? I'm hitting the highlighter key. There we go. Okay. I thought I was anyway. Okay, so we are going to convert this to a fraction with base 10s. So then we're going to say that c is now our new base, where c is our base of 10. So it's going to look like log base c of a over log base c of b, where once again this is an assumed base 10. So really what it is just saying is that we're going to take the log of a divided by the log of b. Okay, base goes to the bottom of the fraction. You're just making a fraction out of these two values. You're making two separate logarithms, the a and the b, a and the b, a and the b, making two separate logarithms. Okay, so we have to figure out what log base 4 of 32 is. So remember, the question is asking, when we're trying to calculate a logarithm, is 4 to what power gives us 32? That's what a logarithm means. Well, okay, again, we could guess and check our way through there, but I want to come up with something that's going to be pretty substantial, like give me a very good approximation, and I don't want to have to take some time to guess and check my way through this. So I'm going to convert this to a common log. It just becomes log of 32 divided by the log of 4. That's it. That's how we're going to type it in. It's two separate logarithms. Okay, it's not the log of 32 divided by 4. It's not the log of 8. Okay, 32 divided by 4. It's not going to give us 8. It's just log of 32 divided by the log of 4. And that's how we're going to type it into the calculator. Log 32, close the parenthesis, divided by the log of 4. That's it. 2.5. Okay, so our answer is 2.5. 2.5. That means 4 to the 2.5 gives us 32. That is the answer. What's log base 6 of 11? So 6 to what power gives us 11? So I'm going to calculate it. Log of 11 divided by the log of 6. Log of 11 divided by the log of 6. 1.338. 1.338. So this is equal to 1.338. So that means if I took 6 to the 1.338 power, I would get about 11. Okay. Log of 24/11 divided by the log of 3. Log of 24 divided by 11, so 24/11, close the parenthesis, divided by the log of 3. 0.71. So 0.71. 3 to the 0.71 gives us 24/11. Okay, so as you can see, this is all this is going to be. Log of 34/35 divided by the log of 5. So again, the bases go to the bottom. Base, bottom, base, bottom, base, bottom. Okay, the other number goes to the top. The other number goes to the top. Okay, so there's all those values. So log of 34/35, log 34 divided by 35, close the parenthesis, forgot what the other number was, and log of 5. Rats. There we go. Divided by the log of 5. Divided by log 5. Enter. So you get negative 0.018. Negative 0.018 equals negative 0.018. 0, oh my goodness, 0.018. So 5 to the negative 0.018 gives you 34/35 approximately. Okay, hopefully you're getting the hang of this. Let's just do these really fast. So we got log of 9.223 divided by the log of 2/7, and then you'll hit enter. Log of 8 divided by the log of 1/4. Okay, so that's exactly how you're going to type these in. So log of 9.223 divided by the log of 2/7. You should get negative, or excuse me, positive. No, it's negative. I was looking at the wrong thing here. Okay, so we should get a negative 1.773. So that means 2/7 to the negative 1.773 gives us about 9.223. And the second one is a negative 4.872. So 1/4 to the negative 4.872 does give us 857. Okay, now remember what I had said is that these have to be greater than 1. Okay, now you can get negative exponents, you just can't have negative bases or negative values. All right, it is now your turn. Use the common logs to evaluate the following. What is log base 14 of 1852? What's log 6/7 of 2,548? On your mark, get set, and go. Welcome back. I hope you enjoyed your ride. Now you're going to do number 2. Go. Alrighty, welcome back. Now let's do some solving with this. Okay, so like I said, the whole point of a logarithm is to be able to solve for an unknown exponent. All right, we need to figure out 4 to what power gives us 193. Again, you could probably check your way through this, but we're going to need a logarithm in order to find this more quickly. So we're going to convert this to a logarithm. So step 1, convert to a logarithm. Okay, so this becomes log base 4 of 193 equals the exponent. Remember, logarithms always equal the exponent. So log base 4 of 193. Now we know how to calculate that. We just did it. So we're going to take the log of 193 divided by the log of 4. And that's going to tell us what our exponent is. So log 193 divided by the log of 4. And what do we get? 3.79. It says 2 decimal places. I'm going to go ahead and round it to 3. That's what our x is equal to. So 4, if you check it, 4 to the 3.796 does give us about 193. Okay, now this is going to be multiple choice, guys. Okay, so just, you could check it back in, plug and chug back in. But when we come to the actual test, I may have this be a short answer. So you're going to want to make sure you know how to do the conversions. Okay, now this one, I wrote this one backwards on purpose. Here is the exponent. This is the base. All right, so if I convert this to a logarithm, log base 5 of 628 equals the exponent. So how do I calculate that? I'm going to take the log of 628 and divide it by the log of 5. So I type that into my calculator, log of 628 divided by the log of 5. Typed in a wrong key here, 628. Okay, so we get 4.003. 5 to the 4.003 gives us about 628. Okay, the yellow again is the exponent. So let's convert to a logarithm. Log base 2 of 97.31 equals the exponent, 3x plus 1. Well, I need to calculate this first. This is just a number. So let's figure out what that is. Log of 97.31 divided by the log of 2 still equals my exponent. So let's calculate that. Log of 97.31 divided by the log of 2. And I get 6 point, so this right here is equal to 6.605. Okay, so I'm going to do a little side problem here. So I get 6.605. That's what that common log is equal to, equals 3x plus 1. Now we just have a normal equation. So I'm going to subtract 1, get 5.605, and then divide by 3. So I end up with 1.868 is equal to x. So now if I take 2 to the 3 times that plus 1, I should get about 97.31. All right, here again, there is the exponent. That's what our logarithm's equal to. So let's convert it to a logarithm. Log base 5 of 873 equals the exponent. Okay, what is log base 5 of 873? Well, let's calculate that. Log of 873 over the log of 5 equals 4x minus 3. All right, now this is again just a number. So log 873 divided by the log of 5. Make sure you're closing parentheses on this, guys. So you end up with 4.207 equals 4x minus 3. So we're going to add 3. So I get 11.207 equals 4x divided by 4. So I end up with 2.802. That is my answer. All right, so you have 2 problems now. Okay, so you are now going to calculate. So again, convert this to a logarithm, change a base. So convert to log, use change a base or common logs, and then calculate or solve. All right, so here you go. Problem number 3, go. Welcome back. Problem 4, go. All right, so you are finished with that. And now if you want me to go through and check your answers really fast, so we can go through and do that. All right, so I'm going to go back up here to the top, just using common logs to evaluate. So we have the log of 1852 divided by the log of 14. So log 1852 divided by the log of 14. So the answer should be 2.851. This one's log of 2,548.31 divided by the log of 6/7. And we end up with a negative 50.8. Oh, that 99 rounds it, so we'll just go negative 50.88. Okay, and then the 2 solving. So we have the log of 31 of 1874.33 is equal to our exponent. So to calculate that, I'm going to take the log of 1874.33 and divide it by the log of 31. And we get our exponent, or our answer, I should say, which is equal to x, which would be 2.19. There's our answer. And the next one, convert to a logarithm. So it's log base 52 of 34,633 is equal to the exponent. Use the change of base or common logs. 34633 divided by the log of 52 is equal to the exponent. So this right here, okay, I calculate that to get the number. And I end up with 2.645 is equal to 8x minus 2. We're going to add 2 to both sides and divide by 8. So my answer is 0.581 is equal to x. Okie dokie. See you later.